Welcome to Math 105, Lesson 7 on Proportional Reasoning. A proportion is two ratios or rates set equal to each other. So a ratio is a comparison of two quantities with the same units, and a rate is a comparison of two quantities with different units. Now, the distinction is not particularly important for our course, but just in case you encounter those terms, I wanted you all to be aware of that. So what we're going to do is we're going to take a look at proportional reasoning in the context of an example. And the example is that there's going to be an office party and 2/3 of the people will attend the party. So what does that mean? It means that 2 out of every 3 people will attend the party. So if we're going to try to figure out how many people are going to attend, we need to create groups that reflect the proportion of people coming. All right, 2 people coming, those are the green people, and the 1 person not coming is the orange person. So if we're going to try to figure out how many people are going to come if more people are invited, then we have to add these groups together in the same ratio. All right, so there's 1 more person not attending, and then we'll add 2 more people are attending. Now if we were to add, let's say, 1 orange and 1 green, that would break the ratio that we're given, so we can't do that. So when we keep adding these groups, we have to add them always in the same ratio. 1 orange to 2 greens. And then we can keep doing this, and what we want to do is add 7 more groups. All right, so there's our original group. We got 1, 2, 3, 4, 5. 6, 7. So now we have 8 groups total, and they're all in the same ratio. So now we can count up the number of people who are going to attend and the number of people who are not going to attend. So we got 2, 4, 6, 8, 10, 12, 14, 16 total people will be attending the party. 8 people will not be attending. So that means 24 people were invited and 16 are attending. So use those facts to complete number 3. We're going to complete that proportion. When proportions are 2 rates or ratios set equal, we have the 1 already. That was the given, 2 attending, 3 invited. And now based on the rest of this information, now we've got 16 attending out of 24 invited. Now since we kept adding these in groups of 3 with 1 not attending and 2 attending, and we're consistent all the way through, that means we have created a true proportion. And now to confirm that, well, we're going to see an equality test, but you don't actually have to do that if you have a calculator. We can just go ahead and divide these with a calculator to make sure the fractions are equal. So 2 divided by 3 gives us rounded 0.67. If we do the same thing over here, we get 0.67. So those are indeed equal. All right, now we'll look at another way of confirming. Because this way we had to round. So you never really know. Do we actually get equal values, or do we round them to be equal? Well, let's make a little more rigorous test with the equality test. And this is something you may have seen before. It's called cross multiplying. So if we have 2 fractions set equal to each other, we can determine if this is true by taking the numerator of one, multiplying by the denominator of the other, and then do it the other way. Numerator times denominator. So you have A times D and B times C. And these should be equal then. So let's test this proportion here by cross multiplying. So we got 10 times 45, right? And then top by bottom, 25 times 18. And on each side, that gives us 450. So that works. And yes, that means that proportion is true. All right, try this out with your turn number 1. We'll do 42 times 55. And we don't know, so question mark there. And on the other side, 100 times 22. And we get 2310 equals 2200. No, that is not equal. So that is not a proportion. But the equality test isn't just good for testing proportions. It's also used for solving proportions. And that's going to be the main way that we use it. Second example, 240 over n equals 15 over 12. Now we can cross multiply, because now we have a variable. So we do n times 15, that's 15n, equals 240 times 12. And I'm multiplying this out. That's 2880. And then divide both sides by 15. And n is 192. Now whenever you solve a proportion, take that value, plug it back in here. Just take your calculator, divide this out, get a decimal, divide this out, get a decimal. Make sure the decimals are equal. So, should never get a proportion wrong, just due to like a silly mistake along the way, because you should check and be able to catch that mistake. Your turn number 2. So 180 over n equals 20 over 15. Cross multiplying, you get 20n in one direction. 180 times 15. That's 2700 divided by 20. That gives us n 135. All right, plug that back in. 180 divided by 135 should equal 20 over 15. And it does. All right, next up, we're going to have some expressions in there, so these will be a little different. Same technique, though. N plus 2 over n minus 3 is 24 over 9. Now, we're going to still cross multiply. Remember to put the binomials in parentheses, because we're going to need to distribute into them. We're multiplying 24 by this entire expression, not just by the end. All right, 24 times n, 24n. And then 24 times negative 3, that's negative 72. On the other side, we get 9n plus 18. Right, 24 minus 9 gives us 15 on the left. 18 to 72 is 90 on the right. We're going to divide by 15, and n equals 6. And then the test, plug it in for n. So it gives us 8 over 3. Once we plug them in and evaluate, and 8 over 3 should equal 24 over 9. Your turn, number 3. Cross multiply, we got 18 times x minus 2. And 2 times 2x minus 7. Doesn't matter which expressions go on which side of the equal sign, we still get the same answer. We're going to distribute in 18x minus 36, and over on this side we get 4x minus 14. I'm going to subtract 4x from each side. That'll move all the x's to the left, and then add 36 each side. And that'll add, take all the numbers and move them to the right. So 14x equals 22 divided by 14, and x equals 22 over 14, and then reduce that to 11 over 7. Make sure if you express an answer with a fraction, that fraction is reduced to lowest terms. Now we're going to look at some application problems. These all involve proportions. In a classroom, 3 out of 28 students have blue eyes. At this rate, if 252 students attend the school, how many have blue eyes? So to set these up, we're going to determine the unknown quantity and assign a variable name. Right. The unknown quantity is generally what the question is asking for. How many have blue eyes in the entire school? So I'm going to define B to be the number of students with blue eyes. Now we're going to create a fraction with 2 related quantities. It says 3 out of 28 students have blue eyes. So that would be 3 blue over 28 students. So there's a 1 rate. And then on the other side, we're going to create another fraction with this format. We know we have 252 students in the school. And we're going to figure out how many have blue eyes. So when placing the students in this fraction, we have to place it in the same way we did here. Students are on the bottom over here. Students must go on the bottom over here. And we don't know how many have blue eyes, so B blue. Blue eyes on top, students on the bottom. As long as you set it consistently, proportion will work. Okay, so we are going to solve this. 28 times B, that's 28B. And then we got 3 times 2, 52. We got 756 there. And we'll divide by 28 and get B equals 27. That means there are 27 students with blue eyes. in the school. Your turn number 4. To make 8 servings of a casserole, 2 cups of carrots are required. At this rate, how many cups of carrots are needed for 36 servings? So here's our 2 related quantities. 2 cups are related to 8 servings. The question asks for the number of cups needed for 36 servings. So C would be the number of cups of carrots. And 36 servings. So we have servings on the bottom, cups on top. We're set up correctly. Cross multiplying gives us 8C equals 2 times 36. So 8C equals 72. Divide by 8 on both sides and C equals 9. So for 36 servings, we need 9 cups of carrots. Next example, we've got a 20-pound bag of grass seed costs $4.60. So those 2 quantities go together. All right, the question is asking for how many pounds of grass seed can be purchased. So we'll define P to be the pounds of grass seed. And that is for $11.50. So we'll go $11.50 on top. And P pounds on the bottom. Gonna mix up my symbols there, pounds and LB for pounds, it's the same thing. Now we can cross multiply. So you got P times 460, so that's 4.6P. And on the right hand side we got 20 times 11.50. So 4.6P gives us 230 divided by 4.6 on each side. And P is 50. So 50 pounds of seed for $11.50. What a bargain. Your turn number 5. For a particular antibiotic, a 180-pound person requires 15 milligrams. At this rate, find the correct dosage for a 150-pound person. All right, let's do a little quick proportional reasoning first. Should the dosage for the 150-pound person be more or less than 15 milligrams? By thinking it through like that, and just in terms of less or more, it's a good way to check your work, other than plugging it back into the fractions. And this type of thinking can catch errors that the checking the fractions cannot, because this checks errors that are errors in setting up the proportion in the first place. So for your turn 5, £180 is associated with 15 milligrams. We're looking for the dosage, so I'm going to define D to be the dosage for a 150-pound person. So on the other side, we got 150 pounds on top and D milligrams on the bottom. Cross multiplying, we got D times 180, that's 180D equals 15 times 150. 180D is 20 to 2250. Divide both sides by 180, and we get 12.5. And the units are milligrams. So I've shown you one way of setting up proportions, but there are quite a few different ways that these can be set up correctly, as long as they're set up consistently. So let's take a look at the proportion 8 pounds over $20. And 10 pounds over $25. I come up with 3 different ways of writing this proportion. Alright, so there's one. And this is a very useful trick. If you ever have 2 fractions that equal to each other, you can always take both fractions and just flip them over. It's still going to be equal. Alright, so there's one alternative. Now next one, we're going to set up to be consistent, except this time I'm going to do pounds on the left, dollars on the right. Alright, so you got the smaller unit over the larger one. So that means that when you do dollars on the right, you have to go smaller over larger. Alright, so there's another way to do it. And if we cross multiply, we still have equal products, 200 this way, 200 this way. And then one more way we can do it, well, let's just flip this thing over once again. And we can actually flip it either way. I could have the pounds on the right. And then $25 over 20 on the left. Kind of looks like 81 there. 8, oh yes, okay. So there's 4 different ways of setting up the proportion. They're all equivalent to each other. Next example involves scaling a photograph. So what we're doing is you're changing the size of the photograph while keeping the proportion of the width to the height consistent. And so the photograph will still look natural. It won't look stretched in any one direction when we change the size. So we got a color photograph that's 5 inches wide and 3 inches tall. So there's 2 related quantities. We get 5 inches wide. And since they're both in inches, make sure you write down wide and tall, or else we won't be able to tell which one's which. All right, so wide over tall. If you'd like to make an enlargement that is 6.6 inches tall, all right, tall stays on the bottom. How wide must the enlargement be? So I'm going to go W inches wide. W is the width of the new picture in inches. All right, now we can go ahead and cross multiply. So this way I got 3W, and this way I got 5 times 6.6. All right, so that's 3W equals 33. And then divide by 3 on both sides, and W equals 11. So the width is 11 inches. Your turn number 6. A digital image is 6 centimeters tall and 8.4 centimeters wide. To fit on a web page, it must be 3.5 centimeters wide. So how tall must the image be? So the two related quantities, 6 centimeters tall and 8.4 centimeters wide. And on the other side, we know that it's 3.5 centimeters wide. So width goes on the bottom there, and the question is asking for how tall must it be, so what should I call that? T centimeters tall on the top. Okay, we got width on the bottom, height on top. So we're set to go. Cross multiply, 8.4 T equals 6 times 3.5. So that gives us 8.4 T is 21, divided by 8.4 on both sides, and T equals 2.5. The units are centimeters, and we're talking about the height. So picture must be 2.5 centimeters tall. This type of calculation is often used in manufacturing to do quality control. We got a printing company found that 6 books had defective printing out of 1,050 books printed. So there's our two related quantities, 6 defects, 1,050 books. Last month, 210 books were defective. So 210, keep the defects on top. And the question is asking for how many books were printed to produce 210 defects. We got books on the bottom, defects on the top. We are set to go. Multiplying here, we got 6b equals 1,050 times 210. So that is 220,000 and 220,500. Divide both sides by 6, and we get 36,750. So 36,750 books were printed. Your turn number 7. A company that manufactures computer chips finds that 5 out of every 100 are defective. If the shipment of 5,400 chips, how many are expected to be defective? There's two related quantities, 5 defects out of 100 chips. And now we're going to create 5,400 chips. And D defects. So you got chips on the bottom, defects on top. Cross multiplying, it gives us 100D equals 5 times 5,400. So 100D is 27,000, and we divide by 100, and we get D equals 270. So they can expect 270 defective chips. Now, sometimes the proportions will contain expressions, and it really depends on how the question is worded. So these are worded in a little bit tricky way. A car with 8 gallons of gas remaining in the tank can travel 220 miles. All right, so there's two related quantities. So that's 8 gallons and 220 miles. The question asks, how many additional gallons of gas does the car need to travel 275 miles? All right. So if we just put a single variable up here, we're going to get the number of gallons required to travel 275 miles. But that's not what the question asked for. The question asked for how many additional gallons, which means how many gallons over 8 do you need? So up here, we need x plus 8. Starting with 8, we're going to add some gallons to it to be able to go 275. Right, so now we can cross multiply. We got 220 times x plus 8. And over here we got 8 times 275. Distributing. We get 220x, and 220 times 8 is 1760. And then on this side, 8 times 275 gives us 2200. Now we'll subtract 1760 from both sides. Subtract here, we get 440. Divide by 220. And x is 2. So 2 additional gallons of gas are needed. So if we plug in then, we're going to do 8 divided by 220, make sure that equals 2 plus 8 or 10 over 275. Your turn, number 8. An investor owns 80 shares of stock and earns a dividend of $280. If the investor wants a dividend of $448, how many additional shares of stock must the investor purchase? And so here's one ratio, or a rate, 80 shares, $280, those two are related. And the amount of dividends we want are 448. And we don't know how many additional shares do we need, so that's x plus 80 over on that side. All right, cross multiply. 280 times x plus 80 equals 80 times 448. Distributing, 280x plus 22,400. And multiplying over here, 80 times 448 gives us 35,840. All right, now we'll subtract 22,400 from each side. We get 280x equals 13,440. Divide by 280 on each side. And x equals 48. So 48 additional shares are needed. So if you add them to 80, that means we need 128 shares to get 448. So you should get the same value if we do 128 over 448 as you do 80 over 280. Now our last example is about a technique that uses proportions and is actually used by wildlife biologists, by conservationists, by anybody who needs to count the number of animals or fish in an area. And it's not realistic to go and count every one. So there's a technique called capture-recapture that can be used to estimate the number of animals in an area by sampling and using proportions. Right, so let's say we have an area here and we're talking about fish in a pond. So here's a pond. Let's say we've got a bunch of fish in the pond. Right? Each one of these is a fish. So we don't want to have to go in and count every fish, because that'll take forever. It's probably impossible as they're swimming all over the place. So what we're going to do is go in and just capture a bunch of fish. So go into a certain area, I'm going to take all these fish. And we take them and we tag them. After we tag them, we release them back in to the pond and let them mix in real well with all the other fish. Now we've got a bunch of tagged fish. All right, so I'm going to take out a few of these and replace them with fish with tags. Those will be the orange ones. And now they're mixing in, they're swimming all over the place. So now we've got a nice mix of tagged and untagged fish all over the pond. So now what we're going to do, after they're all mixed in, now we're going to go back in and get another sample. All right, so I'm going to go back in and just grab a whole bunch of fish. And some of them are going to be tagged, and some of them are not going to be tagged. But if it's well mixed, that proportion of tagged and untagged fish should be the same throughout the entire pond. So this represents a small sample of the whole pond. And we're going to look at this rate and then use that to figure out how many fish there are in the whole pond. Okay, so we're doing this with beans to simulate the fish. So we're just kind of reaching in and taking samples out of a big thing of beans. And let's assume that the number of fish initially tagged were 240. So we went into this area and we tagged 240 fish. And then we go in and get a sample. And the sample has 30 tagged, out of a total number of fish, 200. So those are the two values we want. We want tagged and total. We don't want to work with tagged and untagged because then we have to do an additional calculation later. Might as well just work with tag and total because what we're trying to find is the total fish in the entire pond. So try to be consistent there when setting these up. All right, so there's one of our rates. There's 30 tagged and 200 total. Now we need to complete the proportion. Now these fish up here, these were the tagged fish. So tagged has to go with tag, and that means 240 goes on top, and what we're looking for is the total number of fish. So to keep it consistent, we got tags on top, total on the bottom. Now we can cross multiply. 30 times F goes 200 times 240. All right, multiplying that out, we get 30F equals 48,000. Then divide both sides by 30. And F is 1,600. So that means we can estimate there are about 1,600 fish in the entire pond. Pond, lake, whatever we're talking about. All right, so this is a technique that is actually used. And there are infinite number of applications for proportions. So this ends up being a really important technique. All right, everybody, have a good day.